Okay, let's start graphing trig functions. So what we're going to do is we're going to establish the patterns using a nice sine curve. So we're just going to establish the pattern, nice sine curve, no big deal. So if you think about the unit circle values, so sine of x is 0, so if x is 0, sine of x is 0, if x is pi over 6, sine of x is 1/2. Oh, you mean to say unit circle stuff again? Yeah, you're right. Sine of, if x is pi over 4, then sine of x is √2/2, blah, blah, blah. So if x is pi over 2, then sine of x is 1. So see, this is just a list of the unit circle values. And I went in the negative direction also, because we're going to do that in a minute. So if you're graphing, you're going to say, oh, we've been graphing since we were little kids. But we're transferring the unit circle onto your basic good old-fashioned Cartesian coordinate plane. So let's see what happens when I do that. Let me see 0, 0. Let me see pi over 6 was 1/2. Pi over 4 was √2/2. Pi over 3 was √3/2. Pi over 2 was 1. 2 pi over 3 was √3/2. 3 pi over 4 was blah, blah, blah. Back to √2/2. Wait a second. And then 7 pi over 6 was down here at -1/2. 5 pi over 4 was at -√2/2. 4 pi over 3 was at -√3/3. Was at -1. 5 pi over 3 equals 10. This is a perfect picture, like all my pictures. 1/2. So you're saying, wait a second, I just went one lap around the unit circle. That's what that was. I did all the unit circle values, one lap. So I did one lap around the unit circle, and it makes this nice curve here, which of course would be perfect. Okay, so you got a nice perfect curve. Then you say, well, what if I kept on going? Well, if you started another lap, then naturally you'd keep on going, wouldn't you? If you started another lap, it would keep on going. But this curve right here, from here all the way around, that's one lap right there. So that represents one lap of the unit circle, that curve right there. So that's what we call one period of the unit circle. It's one lap around the unit circle, okay? One lap around the unit circle is what's considered one period. So starting from here all the way around to here where it would start to repeat itself, that's one period. Then somebody says, yeah, but what if we went backwards? If I went to -pi over 6, I would, oh, wait a second. I'm starting to see a pattern here. It makes the same thing, just going the opposite direction. If I could get it accurate. So this guy, so assuming this was all drawn perfectly, assuming this was all drawn perfectly, we'd say I've got one complete curve, started here, up to the max, down to the min, back to the starting point, up to the max, down to the min. So this is what we would call two periods of the unit circle. So it's just repeating this pattern for infinity. Okay, the sine curve is going to be repeating this pattern for infinity. What was I about to yell about? So what I'd say is, wow, this is a real hassle. Doing all of these points to come up with a curve every time, this is a real hassle. Gee, wouldn't it be great if there's something we could do to maybe shorten this up a little bit, to maybe make it just come up with a pattern of points we need. So somebody says, you know what would be good? I don't really need all these points, these rising points, but I do need to know what that max is. Do need to know what that point is right up there at the top. And I do need to know that point right there at the bottom. So I know I'm going from the top to the bottom and just back again. So I'm curving back and forth from the top and the bottom. Okay, I agree completely. We do need to know the maxes and the mins. And for that matter, we really need to know what these middle points here where it's crossing the axis. And eventually that's going to be called the center line. So we do need to know what these points right here are also. Well, it just turns out that these points that we're talking about here the points that we're talking about happen to be and I know if we were in class and I said, what kind of points are these? A bunch of y'all would notice, oh yeah, those are the quadrantals. So that's all we really need to end up doing is graphing the quadrantals. And you're like, oh, so how is this going to help us? Well, this helps us a lot because from now on, if somebody says we need to graph a sine curve, you're just going to say, oh, to graph a sine curve, I'm going to graph a sine curve. So we just established one pattern went from 0 to 2 pi. Well, that's one lap around the circle, isn't it? 0 to 2 pi. So that's what we would call one period of the circle. So we're always going to graph one period to the right of center. So I went one period around the circle. That this would account for one period around one lap around the circle. So we just say, oh yeah, I'm going to need 0. Then I need pi over 2 comma 1, pi comma 0, 3 pi over 2 comma negative 1. So all I really need is the max and the min and those points where it crosses the center line. And the habit we're going to get into is we're always going to go one period to the right of center, one period to the left of center. So we're always going to be going one period to the right, one period to the left. So instead of having to do every single one of these points every time, which is a major pain, I don't want to do all these points. We're just doing the quadrantal values, the maxes and the mins. Now that's going to change when we start doing, it won't be quadrantals anymore. It'll be other kinds of points when we start having transformations. But for now, that's the key thing. So we're going to establish this with sine, but it's going to work the same way for everybody else. The tan and cotan are kind of different, but for sine and cosine, we're only worried about the quadrantals. One period to the right, one period to the left, but they're going to change. It's not going to be the quadrantals all the time. It's going to change once we start maybe having transformations. And then for cosine, it's going to be the same thing. You get with me? All right, so that's the basis for what we're doing. We're graphing, we're stretching out the unit circle. We're stretching out the unit circle on a coordinate plane. Stretching out the unit circle, and it made this nice sine curve. I know you've probably heard that expression before. Made this nice sine curve. One lap around the unit circle is considered one period. One period is one lap around the unit circle. And we're always going to graph two periods. One period to the right of center, one period to the left of center. Okay. So then what comes next is we're going to have lots of transformations that we're going to have to consider. All right.